yeah. Start from any integer k, yeah. Then we must follow these steps, yeah. You don't need to justify why it's okay to start from k, yeah. So you don't have to prove the previous sequence before k, yeah. So let's see an important observation, yeah. 0 is true, 1 true, 2 true, 3 true, 4 true, yeah. To prove P equal P5, yeah, we can only assume P4. We cannot rely on any of our earlier results, yeah. So now we can discuss the strong induction, which is another variant of mathematical induction. The principle of strong induction states that if for some property Pn, yeah, we have that P0 is true, yeah. For any n natural numbers with n not equal to 0, ya, n-nya nggak termasuk ke 0 gitu ya. If Pn prime is true for n prime less than n, then Pn is true. Okay? Okay. Then for any n natural numbers, Pn is true. Okay? So here the keyword is the n prime is less than n, ya. Jadi we want to prove that Pn prime is also true, ya. Yang mana n prime ini kurang dari n. Contohnya misalkan kita punya suppose we have in some natural numbers, ya, we have n equals to 5 gitu kan. Now we have n prime that is equals to 3, which is less than 5. Okay, so we want to prove if P3 is true, then P5 is true. Okay, so okay, let's continue. Yeah, assume that Pn holds for all natural numbers smaller than n. Yeah. Okay, let's see. 0 is true, 1 is true, 2 is true, 3 is true, 4 is true. Okay, so let's see for dominos. Yeah, so here in dominos, meaning that we use the same effort or steps, yeah, the same effort or steps in every steps, ya. Kita menggunakan effort yang sama. Di sini kan ukurannya sama semua, ya, untuk setiap step. Oke, so ketika kita menjatuhkan one of them, ya, we don't have to break every single bar here. We just need to put down the first bar, yeah. We just have to put down the first bar, and then eventually all the bars uh will be lie down, ya, akan jatuh, ya. Okay. Okay. So here, how about we use this analogy for the strong induction. So see here, we don't have to use the same size of bar. Yeah, we can use start from the smaller bar. Yeah, then we can break the rest of the bars. Okay, so let's try to interpret this. Yeah. Okay. So we have two types of induction. Yeah. We have weak and strong inductions. For the weak one, which is the regular induction, is good for showing that some property holds by incrementally adding in one piece. Yeah. Okay. The strong induction, yeah, breaking a large structure down into multiple small pieces. So we don't have uh to uh to prove the large structure here. Yeah, we can just uh use these small pieces to break down some properties. Okay. Okay. State that you are attempting to prove something by strong induction. Okay, to do the proof by strong induction, first we must state that we use proof by strong induction. Yeah, remember strong induction and state what your choice of PN. Yeah, again, still the same. Yeah, we can either explicitly or implicitly state the PN. And then again, we must prove the base case which is P0 or any smallest n. Yeah, prove the inductive step. Yeah, prove the inductive step. So we state that you assume for all 0 is less or equal to n prime, which is also less than n, that Pn prime is true. Yeah. State what Pn is. Yeah. And we can prove Pn. Okay. Okay. Remember the key word here is n prime, which is less than n. Okay? So we can apply this to the binary numbers, yeah. So the binary number system is based to, yeah, every number is represented by ones and zeros, yeah. And for an example, we have 100, yeah, 100 base 2. So we can implement sorry, it's not 100, 100, right? 100 base 2. So 1 times 2 to the power of 2, 0 times 2 to the power of 1, and 2 to the power of 0. Yeah. The key point here is the sequence of powers. Yeah. The sequence of powers here, 2, 1, and 0. So we got 4 here. Okay. Now, how about we have 11011? 11011. So now we can get 2 to the power of 4, 2 to the power of 3. Yeah. Do not forget to multiply with their binary numbers. Yeah. Here, 1, 1, 1, 1, 0, 0, 1, 1, 1, 1. Okay, so now we get 27. Okay, so it is almost frequently used in computing, yeah, because almost all computers do computation by binary, yeah. How do we know that every natural number can be written in binary? Okay, again, okay, we cannot directly prove that every natural number can be written in binary. So, what should we do? We should know what's the definition, how to get the binary number. Yeah. How to get the binary number? Yeah. Binary number is the sum of distinct powers of 2. Distinct powers of 2. Remember? Distinct. Yeah. Distinct. Okay, distinct powers of 2. Yeah. So this says that there's at least one way to write a number in binary. So we need to a separate proof to show that there's exactly one way to do it. Yeah. So before we prove that every natural number can be represented by binary number, we must prove that at least one way to write a number in binary. How to write a number in binary? Based on the sum of distinct powers of 2. Okay, so how do we prove this? Okay, let's see. Ya, mungkin saya jelaskan bahasa Indonesianya dulu ya. Jadi, sebelum kita mulai melakukan pembuktian dalam pembuktian secara langsung bahwa setiap natural number itu bisa direpresentasikan dalam binary, maka kita harus definisikan dulu bagaimana caranya untuk merepresentasikan sebuah angka dalam binary. Oke, gimana caranya? By sum of distinct powers of 2, ya. Nah, kita harus buktikan ini dulu, ya. At least one way. Oke? Paling tidak satu cara. Kalau kita bisa membuktikan ini, maka ini bisa jadi lemma, ya, bisa jadi lemma dan every natural number can be expressed in binary. Oke. 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 So suppose we have 27. Yeah. 27. Now we get to make a binary. Yeah. We must check the largest power of 2 that is less than 27. Kita harus cari uh, angka 2 pangkat berapa yang paling mendekati 27 dan kurang dari 27. Oke. Em, sorry. Hmm, 2 pangkat berapa X yang kurang dari 27 dan yang paling mendekati 27, ya. So, let's check, ya. How about 2 to the power of 2 is 4, ya. So, how about 2 to the power of 3? 8. Okay. Nah, is there any number that is larger than 8 that can be expressed by the power of 2? Let's see. 2 to the power of 4 is 16, yeah. 16. How about 2 to the power of 5? 32. Yeah. Here, it is no longer less than 27, ya tidak lagi kurang dari 27. Maka the largest one will be 16, which is 2 to the power of 4. Okay. Nah, where can we get this 11? By subtracting 27 by 16. So we got 11. Okay. So now we use the same way, yeah. The nearest two powers, yeah. The nearest two powers is 2 to the power of 3, ya. Ini, yang ini. Yang paling mendekati 11. Okay. So we got 8 here. So now 11 kurangi 3 equals to 3. Now we get